The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to go on and start chapter 10.2. We'll spend today and tomorrow on that. Before we do that, we have a question that came in through email. So let's look at that. This is from section 10.1 from yesterday, problem number 9. It says, solve the equation, and we have 8x plus 5, the quantity squared, equals 24. Enter your answers as a comma-separated list, it says. All right, so this equation is already in that special form where we can use the square root property. We have a perfect square on the left side of the equation, which contains the variable x, and a constant on the right side of the equation. So our first move is going to be to take the square root of both sides. In fact, let's do this. Let's rewrite this. So we'll have the square root of the quantity 8x plus 5 squared equals plus or minus the square root of 24. So on the left side of the equation, the square root and the square undo each other, and we have 8x plus 5. On the right side, we have plus or minus the square root of 24, but the square root of 24 is the square root of 4 times 6. Take out the 4, make it a 2 outside, so we have plus or minus 2 square roots of 6. Next, we're going to subtract 5 from both sides of the equation. So we have 8x equals negative 5 plus or minus 2 square roots of 6. And lastly, we'll divide both sides by 8. So x equals negative 5 plus or minus 2 square roots of 6 all over 8. But in WebAssign, you would list them separately. So you'd have x equals negative 5 plus 2 square roots of 6 all over 8, comma, negative 5 minus 2 square roots of 6 all over 8. And again, make sure that comma is not sucked up inside that square root of 6. So you want to use that right arrow in WebAssign to move it to the right so the comma is outside of that first term. Any questions about that? Any other questions from any of you from section 10.1 from yesterday before we go on? All righty, then we shall continue on to section 10.2. So we've learned long ago how to solve a first degree equation. If we had something like 2x plus 4 equals x minus 7. So this is a first degree equation because the highest power of exponent on the variable is a 1 or an implied 1. So to solve this, we put all the x's on one side of the equation and all the constants on the other side of the equation, and we solve the equation. Well, today we're going to start looking at second degree equations, or quadratic equations, as they are called. So second degree or quadratic equations. For example, x squared plus 3x plus 2 equals 0. This is a second degree equation. The highest power on or exponent on any of the variables is a 2. There are several different ways to solve this. One of them, chapter 6, which we don't do in Math 93, covers a way that is involved something called factoring. But today we're going to be using the quadratic formula. And the way that that is derived is if you take a general quadratic equation or second degree equation, and we'll call it ax squared plus bx plus c equals 0, where a, b, and c are numbers. So a is the coefficient of the first term, b is the coefficient of the second term, and c is the constant term. If you have an equation in that form, and you go through a process called completing the square, which we also don't cover in this class, but in the end, the result is this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now keep in mind, a, b, and c are numbers. So x equals all of this, we end up with number answers. And then it becomes a matter of plugging in the numbers in the right place in the formula and then simplifying it. So we can take a second degree equation and solve it by plugging it into this formula. Again, this is called the quadratic formula. You want to memorize this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. What I suggest is, as you're doing your homework, refer back to the try and write out the formula from memory, then check back to make sure it's correct and go on from there. And by the time you're done with the assignment, hopefully you'll have this formula memorized. Well, let's go back to this equation and let's use the quadratic formula to solve it. So we've got x squared plus 3x plus 2 equals 0. Notice that standard form, or the quadratic formula, standard form of a quadratic equation, the descending powers of the variable, then the constant term, and then set equal to 0. So this equation is in that form. A is 1, B is 3, and C is 2. Anybody have any questions where I got the values for A, B, or C? Okay, so now x equals negative b plus or minus the square root of b squared minus 4ac all over 2a becomes x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 2 all over 2 times 1. So again, I substituted these numbers in the place of these letters in this formula. Now it's a matter of simplifying further. X equals negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 is 4 times 2 is 8. So 9 minus 8 all over 2 times 1, which is 2. Continuing to simplify, x equals negative 3 plus or minus the square root of 9 minus 8 is 1 all over 2. Continuing, x equals negative 3 plus or minus, well, the square root of 1 is 1, and that's all over 2. Now, when you get down to this point, if there's no radicals, you can simplify it into two separate answers quite nicely. X is negative 3 plus 1 over 2. X is negative 3 minus 1 over 2. But negative 3 plus 1 is negative 2. That over 2 is negative 1. Negative 3 minus 1 is negative 4. That over 2 is negative 2. So x equals negative 1, comma, negative 2. There are the two solutions. Let's check our work. Let's take this equation and plug in these solutions one at a time to see if they work. We'll do that on the next page. So x squared plus 3x plus 2 equals 0. X equals negative 1 and negative 2. Okay, so let's take negative 1. Negative 1, the quantity squared, plus 3 times negative 1 plus 2 equals 0. Negative 1, the quantity squared, negative 1 times negative 1 is positive 1, plus negative 3 plus 2 equals 0. Well, 1 plus 2 is 3, plus negative 3 would be 0, 0 equals 0, so the first solution checks. Let's take the negative 2 and plug it in. Negative 2, the quantity squared, plus 3 times negative 2 plus 2 equals 0. Negative 2, the quantity squared, or negative 2 times negative 2 is positive 4, plus negative 6 plus 2 is 0. 4 plus 2 is 6, plus negative 6 is 0. 0 equals 0, and the other solution works as well. Any questions about this particular problem? Okay, we're going to look at a bunch more examples then. Let's take the following equation. 6x squared minus x minus 1 equals 0. This second degree or quadratic equation is in standard form, descending powers of the variable. So a is 6, b is -1, and c is also -1. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals +1, because a negative times a negative would be a positive, plus or minus the square root of -1, the quantity squared is 1, and then -4 times 6 would be -24, times a -1 would be a +24, all over 2 times 6, which is 12. X equals 1 plus or minus the square root of 25 over 12. X equals 1 plus or minus the square root of 25 is 5, all over 12. So we've got x equals 1 plus 5 over 12, and x equals 1 minus 5 over 12. 1 plus 5 is 6 over 12 is 1/2. 1 minus 5 is -4 over 12, which is -1/3. So x equals 1/2, comma, and -1/3. Okay. So there's the two solutions to that quadratic equation. All right, let's take a look at this example. X squared minus 18x plus 81 equals 0. This quadratic equation is in standard form. A is 1, B is -18, and C is 81. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals +18 plus or minus, let's see, -18 times -18 would be +324. And then -4 times 1 would be -4, and -4 times 81 is -324, all over 2 times 1 or 2. So x equals 18 plus or minus the square root of 0 over 2. X equals 18 plus or minus, well, the square root of 0 is 0 over 2. Well, 18 plus 0 is 18, and 18 minus 0 is 18. So basically, our only answer is 9. So x equals 9, and we'll say that is a repeated solution. So we still have two solutions, but they're the same number. Both of them are x equals 9. Okay, now those particular equations all came out with nice answers. Let's look at some that don't have such nice answers. This says t squared equals t plus 4. So now we're solving for t rather than x. Our first goal is to get this equation in standard form. I'd like to have my leading coefficient, that is the number in front of the variable squared, to be positive. T squared is on the left side and has a +1 coefficient. So I'm going to leave it there. I'm going to subtract t and subtract 4 from both sides of the equation. So now I have this equation. It's in standard form. A is 1, B is -1, and C is -4. So now we're solving for t rather than x. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. T equals negative times negative is positive 1, plus or minus the square root of negative 1, the quantity squared. Negative 1 times negative 1 is positive 1. Minus 4 times 1 is minus 4 times negative 4 is plus 16, all over 2. So t equals 1 plus or minus the square root of 17 over 2. Now, I can't simplify the square root of 17. So my two answers are t equals 1 plus the square root of 17 over 2 and 1 minus the square root of 17 over 2. This looks like a 2 instead of a 7. Okay. But then the instructions also say approximate the solutions to the nearest hundredth. So what I'm actually going to do is this. I'm going to go back and erase this answer, and I'm going to put it down here. And then we're going to go on and do the decimal approximations for each of those answers. We need to be careful because we're going to use the calculator, but we're going to put this whole quantity into the calculator and then this whole quantity. And we need to note that 2 is the denominator of the entire numerator, not just a part of it. So what I'm going to do is this. I'm going to go to the next screen and recopy those two answers. T equals 1 plus the square root of 17 over 2. T equals 1 minus the square root of 17 over 2. Okay. So for the first one, with my calculator on and cleared, I'm going to put in a left-hand parenthesis. Okay. Then I'm going to put in 1 plus, and then the square root. And when I put, so that's a second function, square root, which gives me a left-hand parentheses. Then I'm going to put in 17. Then I'm going to close up that parentheses. In fact, let's do this. Let's make that one in red. And then I'm going to close up the entire numerator. So I've actually got two sets of parentheses. I've got the one that is around the radicand inside the square root, that is around the 17, and another one that's around the entire numerator, then divided by 2. Okay, if I don't put in this set of parentheses, then it thinks I want this, and that's not going to be correct. So I need to have that set of parentheses as well. Now, if you're using a calculator that when you access the square root, it doesn't give you a left-hand parentheses, then your answer or what you put into the calculator would just look like that. But if there's that left-hand parentheses here, you've got to close it up and then close up the entire numerator. Okay. All right. Now, let's see what happens when we put all that into the calculator. Divided by 2, and I'm getting 2.5615528813. But the directions, where are the directions here? It says approximate the solution to the nearest hundredth. So this is the 10th, this is the 100th. So we would round the 1 down, so we get 2.56. Okay. Now I'm going to go back and do the second one. 1 minus the square root of 17, the whole thing closed up, divided by 2. And I get, what do I get here? Negative 1.5615528813. So the 1 would round down. So here are the exact solutions, and here are the decimal approximations to the nearest hundredth, to 2 decimal places. Any questions about that? Okay. Let's take a look at another example. Let's see here. This says 4w squared plus 1 equals negative 6w. So my leading term is the 4w squared, the variable with a 2 exponent on it. It has a positive coefficient, so I'm going to leave it on that side of the equation, and I'm going to add 6w to both sides of the equation. So here's my quadratic equation in standard form. So now a is 4, b is 6, and c equals 1. W equals negative b plus or minus the square root of b squared minus 4ac all over 2a. W equals negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 4 times 1 minus 16 all over 8. W equals negative 6 plus or minus the square root of 20 all over 8. Now, the square root of 20 is the square root of 4 times 5, which can be simplified down to 2 square roots of 5. So that's going to go in the place of that. So now W equals negative 6 plus or minus 2 square roots of 5 all over 8. Now, if we're just going to go straight to the decimal answer, we could use this and get the correct decimal answer. But if we want the exact answer and we want it simplified, we need to look at the fact that negative 6, 2 square roots of 5, and 8, they're all even, which means I could reduce them down by a 2. So what I'm going to do is I'm going to rewrite it like this. Okay. Then I can simplify that. Negative 3/4 plus or minus 2 over 8 is 1 over 4, and I don't need the 1 in front of the radical 5. So I get that. Okay. And I could actually put that back together as a package if I wanted to. So let's take those and go to the next page. W equals negative 3 plus or minus the square root of 5 over 4. Okay. So writing those as separate answers, you'd have negative 3 plus the square root of 5 all over 4, negative 3 minus the square root of 5 over 4. And you get in WebAssign, you'd separate them with a comma. And then it says to go to decimal approximations. So we're going to have parentheses negative 3 plus the square root of 5. And then close it up, divided by 4. And negative 3 minus the square root of 5 divided by 4. And let's see what we get here. So parentheses negative 3 plus the square root of 5, close it up, close the whole thing up, divided by 4, negative 0.19098. 19098, which rounded to the nearest hundredth, the 0 would round down, so negative 0.19. And then the second one, let's see here, we have negative 1.3090. The 9 would round up, so we get negative 1.31. So here are the exact answers. Here are the decimal approximations to the nearest hundredth. Okay, now let's take a look at some quadratic equations that can have some things done to it before they're put into the quadratic formula to make them easier to deal with. So for instance, let's take this. Negative 5x squared plus 9x minus 2 equals 0. This is in standard form, and there's really nothing wrong with it, but our leading coefficient is negative 5. Now, why is that a problem? Well, in the quadratic formula, the whole thing's divided by 2a. It's just nicer to deal with if your denominator is positive. So if we have a negative a, that's going to throw things off. So we really would like to have a to be a positive number. Well, I could move everything to the other side of the equation, or I could just do this. I could multiply both sides by -1, which would give me 5x squared minus 9x plus 2 equals 0. Okay, so I could do that. And then from there, a is 5, b is -9, and c is 2. Okay, so there's a way you can get your leading coefficient to be positive if necessary. Here's another example. This says 1.6t squared plus 2.4t minus 0.9 equals 0. So a is 1.6, b is 2.4, and c is -0.9. You could plug these values into the quadratic formula and ultimately get the right answer, but it would be easier to get rid of the decimals. Since each one of these needs to have the decimal point moved one place to the right to get rid of them, I'm going to multiply both sides of the equation by 10. 10 times 1.6t squared is 16t squared. 10 times 2.4t is plus 24t. And 10 times minus 0.9 is minus 9 equals 0. So now a is 16, b is 24, c is -9. We could plug those values in to the quadratic formula. So we can get rid of decimals. Another example is where we have fractions. 1/8 x squared plus 1/2 x minus 3/4 equals 0. If we consider each fraction and look at each denominator and find the least common denominator of 8, 4, and 2, and the least common denominator in this particular example is 8. And then if we go back and we multiply each side of the equation by that LCD, we get the following. 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 8 times 0. Reducing across, we get x squared plus 4x minus 6 equals 0. Now a is 1, b is 4, and c is -6. And we can plug those into the quadratic formula. So again, we can get rid of fractions. Lastly, what if we have something like this? 33y squared plus 99y minus 66 equals 0. What if all the terms share a common factor, in this case 33? We could divide each term on both sides of the equation by that in order to reduce the coefficients down. So y squared plus 3y minus 2. Now a is 1, b is 3, and c is -2. And we can plug that into the quadratic formula. So we can, let's see here. We can get rid of a negative coefficient by multiplying both sides by a -1. We can get rid of decimals by multiplying both sides by 10 or maybe 100 if it needs to move 2 places. We can get rid of fractions by multiplying both sides by the least common denominator of all the fractions in the equation. And we can reduce it down by dividing each term on both sides of the equation by the same non-zero number that is a factor of all the coefficients. Okay, let's go back to doing some more examples. This says solve each equation, approximate the solutions to the nearest hundredth when appropriate. And we'll talk about that here in a minute as to when it is appropriate. X squared equals -4/5 x plus 3/2. Okay, so I need to get this thing in standard form. So I'm going to add 5/4 x to both sides, and I'm going to subtract 3/2 from both sides. So I've got x squared plus 5/4 x minus 3/2 equals 0. Okay, so now it's in standard form. To get rid of the fractions, the least common denominator of the implied 1 here, and then the 4 and the 2 would be 4. So I'm going to multiply both sides of the equation by 4. So 4x squared plus 4 times 5/4 x minus 4 times 3/2 equals 4 times 0. 4x squared reduces down, plus 5x reduces down, minus 6 equals 0. So I put it in standard form. I cleared the fractions. So now A is 4, B is 5, and C is -6. Okay. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals -5 plus or minus the square root of 25. And then we've got minus 4 times 4 is -16 times -6 would be plus 96 all over 8. Okay. X equals -5 plus or minus the square root of 121 all over 8. X equals -5 plus or minus, well, the square root of 121 is 11 all over 8. So we've got x equals -5 plus 11 over 8, which is what, 6 over 8 or 3/4. And we've got x equals -5 minus 11 over 8, which is -16 over 8 or -2. So x equals 3/4, comma, -2. Now, approximate the solutions to the nearest hundredth when appropriate. Since these are exact, nice, rational numbers, there's no need to approximate them. If we had like the square root of 2 or something like that, then we'd go out and use the approximating. Okay, let's see here. This one. X times x minus 27 equals 280. So we need to get this equation in standard form. So first of all, we'll distribute. We'll get x squared minus 27x equals 280. I'm going to subtract 280 from both sides of the equation. So x squared minus 27x minus 280 equals 0. So now it's in standard form. My leading coefficient is a +1. There's no decimals, there's no fractions, there's nothing I can divide out to make it smaller. So A is 1, B is -27, and C is -280. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I want to point out that the most common mistakes are made when simplifying inside that radical, just missing a sign or something. So be really careful with the arithmetic. Okay, so we've got x equals negative times negative is +27 plus or minus -27 times -27 would be +729. Then we've got -4 times 1, which is -4 times -280. Negative times negative is positive. 280 times 4 is 1120, and that's all over 2. So x equals 27 plus or minus the square root of, let's see, 1120 plus 729 29 is 1849. No, that's not the year I was born. It's the year I graduated from college, over 2. Now, it'd be really nice if 1849 was a perfect square. So let's find out if it is. I'm going to take the square root of that, and I get 43. So I get 27 plus or minus 43 over 2. So x is 27 plus 43 over 2. 27 minus 43 over 2. Well, 27 plus 43 is 70 over 2, which is 35. 27, let's see here, 27 minus 43 is negative 16 over 2, which is negative 8. So x equals 35, comma, negative 8. So here again, no need to do a decimal approximation because they come out exact. Okay, let's do this one. 120 b squared plus 120b minus 40 equals 0. All right, so this equation is already in standard form in terms of the variable b, but everything ends with a 0. In fact, I could divide each term by 40. You see that, hopefully? So this would be what? 3b squared plus 3b minus 1 equals 0. Now, this is going to be a little bit confusing because our variable is b, but over here I'm going to say a is 3, b is 3, and c is negative 1. This value of b is not the same as the value of b in the equation. The b in the equation is a variable. The b that's circled in red is identifying the constant, okay? So hopefully that won't be too confusing. So now we've got b equals negative 3 plus or minus the square root of 3 squared minus 4 times 3 times negative 1 all over 2 times 3. B is negative 3 plus or minus the square root of 9 plus 12. Negative 4 times 3 is negative 12 times negative 1 is positive 12 all over 6. B is negative 3 plus or minus the square root of 21 all over 6. Now, I could reduce the negative 3 over 6 if I wrote them separately. For instance, if I wrote them like this, and then reduce that down, okay? And there's nothing wrong with that, but I'm not going to reduce it unless this term and this term and this term all share a common thing I can reduce out. So my two exact answers are negative 3 plus the square root of 21 over 6 and negative 3 minus the square root of 21 over 6. However, let's see here, where was that problem? I need to do the decimal approximations. So this would be what, parentheses, negative 3 plus the square root of 21, close parentheses, divided by 6. And again, there's that second set of parentheses in there. So parentheses, negative 3 plus the square root of 21, close up the whole thing, divided by 6. And I'm getting 0.263. The 3 would round down, so it's just going to be 0.26. And then the second one, negative 3 minus the square root of 21 divided by 6. Again, that second set of parentheses if necessary, and we get negative 1.263. So that rounds down there. So here are the exact answers, and here are the decimal approximations. Let's see, let's do one more of these. This one. We've got 1/4 x squared minus 1/6 x minus 1/6 equals 0. So here is a quadratic equation. It's in standard form, but it has fractions. Now, we could use a as 1/4, b as negative 1/6, and c as negative 1/6 and put it into quadratic formula, but I can almost guarantee things will get messy. So it's much better to clear those fractions out first. The LCD of 4 and 6 is 12. So we've got 12 times 1/4 x squared minus 12 times 1/6 x minus 12 times 1/6 equals 12 times 0. Okay, so here, here, and here. All right, so 12 over 4 reduces to 3, 3x squared. 12 over 6 reduces to 2, minus 2x. 12 over 6 reduces to 2, minus 2 equals 12 times 0 is 0. So now we've got it not only in standard form, but we've gotten rid of the fractions. A is 3, b is negative 2, c is negative 2. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 2, negative times negative, plus or minus the square root of 4 plus, what do we have there? Negative 4 times 3 is negative 12 times negative 2 is plus 24 all over 6. X equals 2 plus or minus the square root of 28 all over 6. But the square root of 28 is the square root of 4 times 7 is 2 square roots of 7. So we've got x equals 2 plus or minus 2 square roots of 7 all over 6. But notice 2, 2, and 6 are all even. So I'm going to split them up like this. Then I can reduce them down 1/3, 1/3. So I get, let's see here. Oh, I wrote a 1 there. This should have been 1/3. So 1/3 plus or minus the square root of 7/3. So we get 1 plus or minus the square root of 7 all over 3. Now, those, we're going to list those separately on the next page. 1 plus or minus the square root of 7 over 3. 1 plus or minus the square root of 7 over 3. So we get x equals 1 plus the square root of 7 over 3. X equals 1 minus the square root of 7 all over 3. Going to the calculator, you'd put 1 plus the square root of 7 divided by 3. And 1 minus the square root of 7 divided by 3. Let's see what we get there. Okay, parentheses 1 plus the square root of 7, close it up, close up the whole thing, divided by 3, 1.215. So that's going to be 1.22, rounding to the nearest hundredth. And then second one is negative 0.548, so negative 0.55. Okay, so here are the exact answers, and here are the decimal approximations to the nearest hundredth. All right, so for tonight, section 10.2, you're going to be working on getting acquainted with the quadratic formula. Tomorrow, we'll come back and wrap up section 10.2, looking at some application problems. But so for tonight, section 10.2, part 1. As usual, I'll be back at 1:15 this afternoon with an office hour if you have need of me. Otherwise, have a great day, and I'll stop the recording